All right, welcome everybody. Today we're going to be talking about FP3, which is known as the greatest common factor. Now this is actually a topic that you should know a little bit about already because we've kind of started that discussion. Now, whenever we talk about the greatest common factor, we like to go to this box idea. So I want to draw my box, and I'm going to make sure there's two sections in my box. One for each of the terms of what we're given. So in one part of the box is going to be the 18x, and in the other part is going to be the minus 14. Now, whenever we think about it, what we try to do for the greatest common factor problems is we try to think to ourselves, what's the biggest number that I can divide out of 18 and 14? And with a little bit of work, hopefully you can come up with the idea of, well, I can divide a 2 out of 18 and a 2 out of 14, and that's the biggest number I can divide out of each. Now, before we go much further, we also should be thinking about our variables here. So when we come over here and we think about this, if we notice there's one x here, and there's another term over here, but that one doesn't have an x. Now when we think about this, and we start working on these problems, one thing that's going to be important for us is that in order to divide something out, they both need to have that piece. So in this one, since they both don't have an x, you're not going to be able to pull an x out of both of them. So let's just carry on here for a minute. So when we come over there, what we really just did is we took each of those terms, this term, and we divided them by 2. So if I took 18 divided by 2, then what I would be left with is 9. Now, it's important to realize here that this original term was 18x, and we haven't pulled out any x's, so we do still have an x that's remaining there. Now, for our other term, if I take negative 14 and I divide that by 2, I would get a negative 7. So I'm going to have a minus 7 there. Now, this 2, the piece that we divided out, is known as our greatest common factor. So I want to show you exactly how your homework is going to look for you. So in your homework on Schoology, you're going to kind of need to give me two things. The first thing you're going to be giving me is the greatest common factor. And the second thing, they're going to ask you for the factored form. Now, whenever we talk about this, the greatest common factor is the number that we pulled out. So that's going to be the 2. Now, for the factored form, the way your assignment will be set up on Schoology is it's going to pre-set up some blanks for you. So in this one, it would look like this. So we would have a blank minus, I should have an x here, minus blank. So this will all be pre-set up, and you're just going to need to put the correct number in the correct spot. So here's how we do it. Whenever we try to write this in factored form, our greatest common factor is the number that goes on the outside. One thing to note, this and this will always be the same number. The other part is this information that we have up on top of our box, that's what's going to end up going inside the parentheses over here. So in this particular situation, the 9 is in front of the x, and then it's minus 7, just like so. So this is what every Schoology homework submission problem is going to look like. It's how your test is going to look too. So we want to practice it now a little bit. Here's our next problem. So looking over here at problem number 3, again, we're going to start by just making our box. We're going to have two sections, one for 24 and the other one for minus 6m. Now, when we come over here and we work through this problem, we want to think, what's the biggest number that we can divide out? And when we think about 24 and 6, hopefully we realize that 6 goes into each of them. So since 6 goes into each of them, now we just need to think, right? So they both don't have an m, so I can't pull out any m's. So once I realize that 6 divides in, then we just want to check on our calculator. If I divided 24 by 6, then I would be left with just a 4 here. And if I divided negative 6 by 6, then I would be left with a negative 1. Now, we can't forget this one had an m, and we didn't pull out any m, so it's still going to have that m sitting there. So our final answer, or our factored form, will have the 6 on the outside, and then we will have 4 minus 1m. And it's just important to remember that this number on the outside is that greatest common factor. We call it the GCF. And that's really what we're here today to work on. So let's look at problem number 5. Looking at problem number 5, again, we're going to start with 2 boxes. Or I guess I should say 1 box, but with 2 parts. We'll have negative 4b squared in the first one, and then plus 6b in the second one. Now, this problem's kind of unique. And the reason this problem is unique is because there is this negative sign on our leading term. Our leading term is like our first one. So whenever we see this negative sign, we want to make sure that we're just intentional and we pull that out to start. So here's what I mean by that. So when I look at my numbers, 4 and 6, the biggest number that I can divide out of each of those would be a 2. So I'm going to divide each of those by 2. Now, since there was this negative, that was our leading term there, we're going to divide out a negative at this point as well. So now we've pulled out a negative 2, so now we should check. Well, actually, let's check our variables. So looking at our variables, we have b's here and b's there. Great. So since this one has 2 b's and this one has 1 b, since they both have a b, we're going to be able to pull a b out. Now, sometimes you can pull out multiple b's, but it really depends on how many b's everything has. So in this situation, our first set of them, we had 2 b's. And in our second set, we only had 1 b. You can only take out as many as the fewest one has. So since this one only has 1 b, we're only allowed to have 1 b over here. Great job. Now, let's continue on and figure out the top numbers. So if I take negative 4 divided by a negative 2, that would leave me with a positive 2. Now, we started with 2 b's over here, and we just pulled out 1 b, which means we're just left with 1 b up top. Now, as we look at the next term, if I take 6 divided by a negative 2, that would leave me with a negative 3 up top. And then over here, we started with 1 b, and we pulled 1 b out, so we don't have any b's left. So our final answer on this problem is going to be negative 2b, and then 2b minus 3. And again, this is our greatest common factor. Great job. Let's look at problem number 7. So when we look at problem number 7, again, we should start out with a box with 2 sections. So coming over here, we're going to have our 7x to the 4th in the first box, and in the second box, we're going to have 28x to the 5th. Now, as we come over here and work through this problem, we should think to ourselves, what's the biggest number that goes into 7 and 28? And in this situation, the answer is 7. So you can divide 7 out of each of those. Now, as we look further at this, we notice they both have x's. So we can take out x's for sure. Now remember, you can only take out as many x's as the fewest one had. So this one had 4 and this one had 5. So since 4 is smaller than 5, we can only take out 4 x's. Now let's work on the top. So 7 divided by 7 would give us 1. We started with 4 x's and we pulled out 4 x's, so there's no x's left. Let's go to the next term. 28 divided by 7 would be 4. Now that 4 is positive, so we're going to put a plus here. We started with 5 x's, and then we pulled out 4 x's. Well, if I had 5 and I take 4 away, I would be left with 1x. So my final answer here will be 7x to the 4th times 1 plus 4x. Making that my final answer. Let's look at problem number 9. So, on problem number 9, we're going to start by making our box. We'll have our negative 3a squared here, and our negative 30a here. Now, remember, if the first term is negative, like this one is, we need to make sure we pull out the negative. So, looking at this problem, what number goes into 30 and 3? Hopefully you come up with the answer of, well, 3 does. So since this one's negative, we're going to make sure we pull out a negative. We only do this if this first box it has a negative in it. Now, if we notice, they both have a's, so we are going to be able to pull out an a over here. Now, this one has 1a, and this one has 2 a's, so we're going to be able to pull out 1 since 1 is smaller than 2. You can never pull out more a's than you have in each of your terms. So now negative 3 divided by a negative 3 would mean we have a 1 up top. And then if I started with 2 a's and I took 1 away, I would be left with 1a. If I take negative 30 and I divide that by a negative 3, that would leave me with 10. And 10's positive, so we're going to have a plus here. Now I started with 1a and I took 1 away, so I don't have any a's left. So my final answer here will be negative 3a times 1a plus 10. And this will be my final answer. Let's look at problem number 11. So problem number 11 is a little weird because there's no numbers in it. So let's put a 1 in front of each of these because we're allowed to do that in math. Now this one has 3 terms, so when we make our box, we're going to need 3 compartments. So we'll have our 1, a, b to the third, c in the first box, and then we'll have minus 1, a to the second, b, c to the second, and then we'll get our last box, which will just be plus 1, a, b to the second, c. Now, when we come over here, the biggest number I can pull out of 1, negative 1, and 1 would be a 1. Now, each of our terms here has an a. This one has 1a, this one has 2 a's, and this one has 1a. Since 1 is smaller than 2, we can pull out 1a. Now we go to the next one. Let's look at the b's. This one had 3 b's, this one had 1 b, and this one had 2 b's. Since 1 is smaller than 2 and 3, we can pull out 1b. Last but not least, if we look at the c's, this one had 1, this one had 2, and this one had 1. We can pull out as many as the smallest one had. So 1 is smaller than 2, so we can pull out 1. So we're going to divide out of each of those 1 a, b, c. Now, 1 divided by 1 is just going to leave us with 1. In this problem, I started out with 1a here, and I pulled out 1a, so I don't have any a's left. I started with 3 b's, and I pulled out 1 b, so that must mean I have 2 b's that are left. And then I started with 1c, and I pulled out 1c, so I don't have any c's left. Great, the first one's done. Now let's go to the second one. Now, if I take negative 1 divided by 1, I'm going to get a negative 1 here. This one, we started with 2 a's, we pulled out 1a. So if I had 2 and I lost 1, I would still have 1 left. I had 1b, and we pulled out a b, so we don't have any b's left. And then I had 2 c's, and I only pulled out 1 c, so that must mean I have 1 c remaining. Great, let's go to the last one. So if I take 1 divided by 1, again we get a 1, and it's positive, so I'm going to be able to say plus 1. Now in this one, we started with 1a, and we pulled out an a, so we don't have any a's left. We started with 2 b's, we only pulled out 1, so we do have an extra b. And we started with 1c, and we pulled out 1c, so we don't have any other c's, which means my final answer will be 1 a, b, c times 1b squared minus 1ac plus 1b. And this would be my final answer. Great job. Let's look at our last problem. Here's number 13. So again, on this problem, our box is going to need to have 3 sections. So in the first one, I have 52, m to the 4th, then minus 26, m to the 3rd, and then plus 13, m to the 5th. Now, as I move through this problem, I need to find what's the biggest number that goes into each of those. Now, there's not many numbers that go into 13, but I do know that 13 times 2 is 26, so that means 13 has to go into 26. Let's see if 13 goes into 52. To do that, I can take 52 and divide it by 13. And since it gives me a nice answer of 4, we know that it goes in there. So here's what we're going to do. We're going to be able to divide 13 out of each of those numbers. Now, we also have m's here to consider. This one had 4 m's, this one had 3, and this one had 5. Since 3 is smaller than 4 and 5, we're going to be able to pull out 3 m's. Now we go to the top. So 52 divided by 13, that gives us 4. We started with 4m, we lost 3, so we do have 1 that's left. Then we go to the next term. Negative 26 divided by 13, hey, that's negative 2. We started with 3m's, we pulled out 3m's, so we don't have any m's left there. Now let's go to the last one. 13 divided by 13 is 1. We started with 5m's, and then we lost 3 of them, so we do have 2 that are left. So our final answer here will be 13 m to the third. That's on the outside. And then on the inside of my parentheses, I'm going to have 4m minus 2 plus 1m squared. Remember, ladies and gentlemen, this is a really important skill. So if you're having any struggles with this at all, please don't hesitate to reach out and ask. Thanks for watching. Have a good day.